Welcome to my channel. Today we will discuss the problem of electric field. The problem is that two charges Q1 and Q2. We can see in the figure two charges Q1 and Q2 are placed 30 cm apart. Okay. Another charge Q3 is moving from point C to D along the arc of a circle of radius 40 cm. Okay. We need to find out the change in potential energy during this process. If the change in potential energy is Q3 by 4 pi epsilon 0 into K, then we need to find out the value of K. Okay. We now come to the problem. In the figure, at point A, Q1 charge is placed and at point B, Q2 charge is placed. And the distance between them is 30 cm. We can convert it into meter. And the distance between point A and C, which is the initial position of the charge Q3, is 40 cm. Or we can convert it into meter, 0.4 meter. Okay. Initially, total potential energy of the system, we need to find out the total potential energy of the system initially. Okay, we can write it UI for initial potential energy. So the potential energy which is acts between Q1 and Q2 charges 1 by 4 pi epsilon 0 Q1 Q2 by R. R means the distance between them, which is 0.3 meter. Okay. Potential energy between charge Q1 and Q3, which is 1 by 4 pi epsilon 0 Q1 Q3, and the distance between them is 0.4. Okay. Now the last one, the potential energy between Q2 and Q3, which is 1 by 4 pi epsilon 0 Q2 Q3 divided by R. We can easily find out that the distance is, we can find out the distance BC is equal to 0.3 square and 0.4 square. We have applied Pythagoras theorem to find it. That is 0.5 meters. We can put it here. So total initial potential energy of the system is, we can write it this way. Okay. First portion is done. This is equation 1. Now we need to find out the final potential energy. Actually, the Q3 charge is moving along this arc from point C to point D. So when the Q3 charge is reached at point D, we need to find out the final potential energy of the system. Final potential energy of the system. We can denote it by UF for final. Okay. Now, the potential energy between Q1 and Q2 is Q1 Q2 divided by R, which is 0.3, and the potential energy between Q2 and Q3, because now the Q3 charge is at the point P. this distance is 0.1 meter. How can I find it? This total distance is 0.4 meter. So this is also the radius of the arc. So this one is also 0.4 meter. Then this distance BD is 0.1 meter. So 1 4 pi epsilon 0 Q2 Q3 0.1. Then the potential energy between Q1 and Q3 this total distance is 0.4. Okay. We have find out the final potential energy. This is the equation 2. So we have final potential energy and initial potential energy. So we can easily find out the change in potential energy, which is UF minus UY. So change in potential energy is UF by UY. If I subtract equation 2 from equation 1, then we can get 1 by 4 pi epsilon 0 Q1 Q2 0.1 minus Q2 Q3 0.5. Okay. Now as per question, this change in potential energy is equal to Q3 by 4 pi epsilon 0 into K. So we can write this is Q3. Q2, Q3, 0.1, Q2, Q3, 0.5, which is equal to Q3 by 4 pi epsilon 0 into K. So if I calculate this, then we get Q3 4 pi epsilon 0 K. We can cancel 4 pi epsilon 0 from both sides, Q3 from this side, and if we calculate this, we can get K is equal to Q2 10 minus 2, that is 8Q. So the value of the K is 8Q2. If the question is the question is change in potential energy. If we need to find out the total work done for this process, we also calculate the work done in the same way, because we know potential energy, change in potential energy is equal to the work done. So we can also write here work done is equal to delta U. That means final potential energy minus initial potential energy. So change in potential energy. I think it is clear to all. If you have any inquiry, then you can write us, and please share and subscribe my channel.